asked by Anna and the iEarth group here in Bergen to give you a little bit of accounting of the project that we got funded this spring from the Olav Thun Foundation. We applied for one of the funds that they have for a research project for student active learning and research. And the focus of our application was marine competence for the 21st century, a new vision for education and training in marine geology and paleoceanography. And we got funded for 3 years. And the purpose of this project is to revitalize an already ongoing class that's been successfully run every spring in marine geology and geophysics lab and field class. But we want to bring some new thoughts to it. And first, I want to talk a little bit about the motivation and the challenges for this class and why we wanted to renew it. The foremost reason is that a very good colleague is going to retire. So last year, he said that maybe the research group should start thinking about how we're going to take over this class and keep on running it. And me and Ulysses sat down and talked about how we wanted this class to continue for the future, and maybe also bringing new aspects into this class. So for the next 3 years, the class will be kind of slowly being taken over and changed, but at the same time, keeping the major part of what's been a success of this class. And I think I would recommend many people to think if there are classes that are going to be changed, if people are retiring, the Thun Foundation is a great way to get money to revitalize the class. And also that classes, I think, should be brought over that way, not just like terminated and somebody else take over a class. This is a great way of carrying through what are major aspects of the research field. So let's see if I can get this to run. There we go. So, I mean, my focus as a marine scientist is to see the planet like this. I mean, after all, 71% of the Earth's surface is water. 97% of the Earth's water is in the ocean. And you can all kind of think about the oceans as the Earth's life support system. And Norway as a nation has a special and plays a special role in this. We are a small nation, but when it comes to the maritime part of our country, we are huge. We are one of the world's leading ocean nations. We have one of the largest and longest coastlines in the world. And we also govern an area in the ocean which is 5 times larger than a mainland of our nation. And almost 70% of our national income is coming from the maritime sector, within oil and gas, technology, or seafood. And in 2019, our government put on an ocean strategy called Blue Opportunities, Blå muligheter. And the goal for this government report is that Norway simply is going to be best in the ocean. And we're going to keep on building on our ocean income, our ocean industry, and our ocean research. And also at the same time stimulate to new research, innovation, and technology development to evaluate and keep on growing and creating new blue jobs. But the future growth also means that we see the ocean holistically to try to understand it. So research, knowledge, and education is not just central to understand the ocean, but also will be the driving engine in getting this blue growth. And in a paper published in 2014, where Martin Wiesbeck was the lead author, it's really given us challenges to view the ocean more sustainable, and also gives us challenges and responsibility that will demand a deeper knowledge about the ocean systems. So these are some of the drivers and some of the paperwork that we looked into when we thought about a new class. Because when we're going to put even more pressure on the ocean, getting more food for the ocean, getting our future energy from the ocean, think about the ocean more holistically, from the deepest part of the abyss until the coastal areas, it's important that a new generation of ocean researchers gets the skill and get the education that give them the possibility to deal with these very complex challenges in the real world. So to develop new study programs with high quality is a central part of this engine to drive innovation, drive sustainability, and develop in the marine sector. But a lot of reports are showing, for instance, these that are coming from the European Marine Board. I was Norway's representative to the European Marine Board for 5 years and was part of releasing this Rome Declaration and also navigating the future, the position paper from the Marine Board. And there is a what we want and what is actually happening. Those two are not balanced, because these reports are showing that what we offer for education at European universities and the need for what we need in the future in terms of the blue economy are not matching. So both in the 2013 and the 2014 report, the European Marine Board pointed out that the education within the marine sciences were a tiny part of the study programs at most European universities and colleges. And that has not been significantly changed over the last 5 years. So in 2018, this report came out, Training the 21st Century Marine Professionals. And obviously this has been a great inspiration for us in thinking new. And they also raised important questions about the research-based, whether current mode of higher education equips the students in the marine subjects with the necessary skills and knowledge for modern working life, both within and outside academia. So our vision to meet these challenges was to develop a research-based teaching portfolio in marine geology and paleoceanography. This is the first of several classes that we hope to renew, and also hope to start some new classes at the department at the university here. And our goal is to give the students teaching and learning and disciplinary and transferable generical skills and experiences, both from the academic, but also down the road, also from non-academic workplaces. I know that one of the pillars of iEarth is also to train the students that they could get experience in companies, and maybe also invite companies and non-academic institutions in to be part of our teaching. And down the road, this is something that we want to expand this class to incorporate. But so far, this is not part of this 3-year plan. But in the suggested class, we want to develop a big menu of skills, including solving complex problems, critical thinking, teamwork, creativity, communication, and project management. And the course will have a strong focus on student active learning forms and also assessments that will promote learning. So the environment that we can offer here in Bergen for this class is really great. We have a marine field station that we want to have a kickoff class at. We want to, since our main area of studies are the unique archives that are in the fjords and in the shallow water setting along the coast, we want to have a kickoff class where we start with sort of Fjord 101 classes. We have really great boat facilities through this research collaboration that we have with the Ocean Research Institute. We have access to state-of-the-art research vessels with geosars, where the student cruises are going to take place. We have access to national infrastructures like FARLab, the Facility for Advanced Isotopic Research, monitoring of weather, climate, and biogeochemical cycling. And we want to build on and start new measuring series, measuring oxygen and pH in the fjords, and select the areas that we every year will return to build on these measuring series. We also have now stable isotope mass spectrometers that we can bring out at sea. It was just successfully deployed on a 3-week cruise out now with the Irish research vessel, where water samples and pore water from the sediments and pH, oxygen, and nutrients were measured on site on the boat. We also have the NORMAR, the Norwegian Marine Robotics Facility, here at the department. And first and foremost, we also have Earth Lab, which is the Earth Surface Sediment Laboratory, with a lot of advanced machines and techniques that are going to be facilitated in this class. I mean, the research and why we have a class in marine geology and marine geophysics is very clear. And we are a very, very unique setting here in Norway, with the coastal currents making a huge climatic difference for our coast compared to other latitudes. And the influence of the Norwegian currents on our climate, on our fjord, on our coastal water, it's really a unique topic. And we also know that our currents are part of a huge global conveyor belt, and monitoring this and also reconstructing how these unique marine systems have changed through different geological periods and also through different background forcing is going to be a fundamental part of this class. Very often we just think about these ocean currents as they're almost like a river just going along our coast, but in the Poleward project, you can see down here to the right, you see when they let a lot of buoys out, you can see the trajectories of the coastal currents. And some of these measuring series are important to tap into, to continue, but also to reconstruct back in time. So this is a fundamental part of the research that goes into this class. And we also know that global warming is changing the coastal water. These are measuring stations where the data goes back to the 30s along the coast, and we're clearly seeing the warming of the Norwegian coastal water. The warming also leads to that they are less dense, and this change in heat and density is definitely changing what's entering a fjord. So the coastal water is warmer, the coastal water is less dense. That also means that the coastal water more and more rarely enters the fjords. And we're seeing that some of the fjords in Western Norway becomes less and less oxygenated. So this is also very, very important knowledge to bring into a class and do hands-on measurements in the field and evaluate that versus changes in other fjord systems in the world and other fjord systems along our own coast, and tap into this. We also know that we have to provide knowledge about, there's a lot of future cabling that's going to happen from this region to England, to Scotland, and marine geophysics and the knowledge of the bottom seafloor and to submarine slides, et cetera, is extremely important knowledge. And we're thinking that there could be like cases every year where we actually maybe work with companies, or maybe some of our hypotheses and research questions that we try to solve with the crews where we're going out to do the field expedition, could we try to answer some of these really urgent knowledge that society needs. For instance, this is showing this is data from Inju, showing how in the harbor of Kristiansand, when you're filling masses, cost a submarine landslide. So this is also knowledge that is important to try to map some of these landslides, see what they're related to, and also again reflect over that how that knowledge is important in society. And I could have added marine pollution to this as well, but there are very many aspects that this class will cover, already covers, but we need to cover more. So the main purpose of the project is to develop a module-based course in marine geology and paleoceanography with a focus on a three-dimensional competence understanding, where competence is the sum of knowledge we want the students to know, we want the students to incorporate skills, we want them to do stuff, and we want them to understand, to comprehend. And the competence will be achieved through research-based teaching, training, experience in the marine field, and laboratory techniques. And it encompasses two of the fields in marine science: marine geology, including geophysical, geochemical, sedimentological, and paleontological exploration of the seabed and area of the coast. And marine geology has strong ties to physical oceanography and to plate tectonics. And then paleoceanography, which is the study of geological history of the ocean, and includes circulation, chemistry, biology, geology, sedimentation patterns, and biological productivity. Paleoceanography uses models, and various proxy data to understand the process of the global climate by reconstructing past climates from marine sediments archives. And as I said, we were going to develop this class over 3 years. We got funding. So this for the next 3 years, I've been bought free a little bit to develop this class. We are going to work with the teaching lab here at the university down at Media City to make some movies, to make training, to make digital modules for the class. Yeah, we'll see. I can just go on and see and we start talking a little bit about how the class is built up. So it's built up like 4 modules that build on each other, and each module will have different assessment forms. So module 1 will be blended learning and virtual field methods. And so this is the major part that's going to be built up now, and that I have started on, or we have started on. So the first module is to build knowledge and skills. So this is the training before we go on a cruise. So we will design this module as a digital learning activity using, for instance, blended learning techniques. We're going to build up digital modules, quizzes, and we're also going to build almost like a virtual ship that the students can train on different laboratory techniques. So blended learning will combine both seminars, gathering, where we physically meet and discuss, but also digital learning modules where the students will train and reach kind of different knowledge levels, and then kind of feed back into that. So the point is to take advantage of both the strengths of digital learning, but also non-digital teaching methods in a way that we hope will make the overall learning outcomes much stronger. So the interesting thing, as we well know with field and going out at sea, is that we can take the theory and put it into action, put it into practical usage. So the skills that they build on campus is what they're going to use when they enter the boat. But often when you go out at sea, if you just basically kind of show up of the boat, we don't often always knows what traces to look for. For instance, when we're looking at sediments, or when we're looking at the seismics, what is hemipelagical sediments? What is the surface structures? What are how does the core look? How do we log and work with the core? And how do we interpret seismic? Or how do we actually also maybe decide where to go and look and decide where our seismic lines are going to go and where we're going to get our course? Therefore, it's really important to train the students beforehand in observations and interpretation tools, both using their eyes, in a way, putting the geo glasses on and start thinking as a geologist, and learning not just like the major concept, but learning the techniques of how to interpret. Because that will help them in the field to observe patterns and traces and couple this to their geoscience knowledge. So in this way, both the observation and interpretation tools is going to work in a way like a lens that they put on to understand geology. So by using the infrastructure that we have at hand here in the department, in the labs, and also by using the new digital teaching resources and movies that we're going to make, we're inviting the students to participate in a virtual cruise. And one of the reasons why we want to do this is that a boat like GeoSARX is an immensely expensive infrastructure to use. We're incredibly happy and lucky to have access to it and to go out on not just mimicking a scientific cruise, but actually taking the students out in what would be otherwise like a huge group of national and international researchers going on a huge research expedition. We're going to mimic that, but by doing that, we also have to train beforehand. And the inspiration for this virtual cruise is what the International Ocean Discovery Project, IODP, does and provides down in Bremen. So we're also going to work a little bit with our colleagues in Bremen, where they built up a full-scale virtual ship digitally that they want researchers to train on before they go on the big drill ships. So we're hoping that this could be a little bit exciting for the student and also give them an understanding of the high standards that's required when it comes to do accurate measurements. How do you evaluate that the precision, for instance? How do you do logs? How do you do methods analysis? How do you reproduce your analysis? What standards are we using? This is what is demanded in marine geological research. This is what's asked for when you're continuing in the field, and this is also what you need to start your master's. So the students are going to work in groups with authentical field data like seismic, sedimentary cores, water samples, microfossils, smear slides, etc. So once we finish that module, we're moving to module 2, which is the student-led hypothesis in field design. So having built the skills in module 1, we're going to start with module 2, where they're going to start looking at state-of-the-art, recent marine geological and paleoceanography research, and papers that's been published, maybe previous reports also from the cruise, and they're going to start work out their own hypothesis for what the field class is going to be about. What are we going to try to answer? And here it could be things that are related to, for instance, like this year we're going to have focus on submarine slides to make sure we need that knowledge for where to cable safe. Maybe we need to know where is a good place to put windmills offshore. Maybe where would be okay to put a bridge. Or maybe it was simple to be, this year we're going to have focus on finding out basically what's happening in the fjords in terms of like water that's going in terms of oxygenation, more of a paleoceanographical context. Or maybe all of that will be part of the cruise, and the groups will have different focuses. So the students are going to work in groups. They're going to sketch the field design, plan the entire cruise using digital mapping tools, information about currents, tidal waters, where it's safe to go in terms of power cables or not, and also, evaluate the possibilities and the limitations of the study area they're choosing. And they're also going to plan the cruise with, in terms of like night and day shifts, and plan sampling, and start also planning what to bring on the cruise and be part of packing for the cruise. So they're really going to be hands-on and really integrated in what we're doing, just like we're doing as scientists. So module 3, finally, we're going on the cruise. We're doing the field experiment. We're going to gather, analyze, and then also later on the students are going to present from the cruise. So after this virtual module and after the theoretical modules, finally a practical part, the cruise with the following group work that will have focus on both analysis and interpretation of the material that's been gathered during the cruise and the data. And every group will be responsible for all the research activity on board during their shift, to get water samples, to get temperature, density, salinity measurements to the water column, to take surface samples, to take long and short core samples. And different analysis will already be done on board. For instance, if we bring the stable isotope mass spectrometers on board to measure the seawaters and pore waters. And after the cruise, the students will further analyze and interpret the results and work in the lab with producing data from the sediment cores, scan them, do XRF, do MST, and do core logging, look at colors, look at analysis, do microscopy work, do further isotope analysis, do grain size analysis, do basically the full suite what's needed to interpret the data. And then they will analyze and interpret the results and compare them to existing research data. The goal here is that the students get training in different analytical and numerical methods to answer the research questions. And the students will contribute to write the cruise report and also present the results. So in module 4, which is the synthesis and usage of it, is to use the data and research to critically reflect over the results from the cruise in relation to their original hypothesis or their original research question, to try to identify if they've developed new knowledge and evaluate the certainty and uncertainty in the new knowledge. We want the students to evaluate and identify what is important in terms of what they've done, both scientifically, but also society-wise. And every group should evaluate a case study from a marine geological case problem in society and try to use marine geological knowledge, experience, and understanding to propose solutions. It could be, whether we're actually going to have tailings from mines, depots in fjord, it could be submarine landslides, where to put cables, offshore advanced bridge solutions, etc., etc. Floating offshore windmills, marine pollution, ocean pH changes, etc., etc. And this part of the class is the module that we see that could be further developed down the road, maybe with getting in touch with companies in the region here that students can go and have practice with, or we can have people from companies to come in and give seminars, or we can have company visits, etc. So this is the module that down the road is going to be developed much more, because we want to have a focus that could be a future practical part of this, where the students are out in companies. And maybe that could be a separate class down the road. So research on teaching, they tell us, and then it's the whole background for why we got iEarth funded, that the student's own activity in the learning situation is really important for the effect of teaching. And a book that I read parts of for this application, Students, the University's Unspent Resource, Revolutionizing Higher Education Through Active Student Participation by Gardebu and Vigbat. It was published in 2012. It's clearly showing us that student active learning is more than the active learning forms. Starting out, I've taken a lot of Uniped classes, pedagogics classes, and it's very easy to get hooked up in how I'm going to get the students active. But it's also important to see how much it's important that the students get the central role, that the students get an active role in the planning, and also get an active role in suggesting assessments, and also constantly evaluating the class, so that we can build this class stronger and stronger. So that's going to be, I think, a big challenge for us that's going to lecture this class, to get to that point where the students are an active part of the class on very many levels, not just as sort of passive students, but part of the lecturing and part of the learning process themselves. So of course, we're gonna, as teachers and lecturers, define the content and maybe also the starting shape of how this class is, because we know the theory, we know the empirics, but down the road, our vision is that the students, as they get more and more familiar with the subjects in this class, that they can come with feedbacks on how they think the focus should be, that they can, through their own sort of ownership of the field work, also devise how they want to present the work, how they want the work assessed, etc., etc. So we know that sometimes what's stopping these sort of almost like organic processes is very often student admin. I'm sorry if you're listening, I'm not after you, but it's very conformed sometimes how we're allowed to assess a class. We always have to decide beforehand how a class is assessed. It would be interesting to see if we could have developed a class where assessment is happening more sort of organically through the class, but we'll see how that can develop as this is more institutionalized. We want to try to have different assessment forms for each module. We want digital models that the students should answer. It could be quizzes. We want to have a poster presentation when it comes to the cruise design. We want to have them write a cruise report and also write a popular science paper based on their case study, the case study that I mentioned in module 4. And we also want to test out sort of different components for what you call a collaborative evaluation, where students are first doing maybe a problem set on their own, then they pair and do it together, and do it as a group also. This is the exact same problem sets. And there is research done used in oceanography classes at University of Amherst that inspired me to look into this. And I think that could be an interesting casework here because the whole field class is based on that we're going to work in groups. So why not also assess the groups? Let me see if I have any more slides. Yeah, this I didn't bother to translate. So I hope, I don't know if we're going to put out this PowerPoint on that. Maybe people can read through it. This is just the learning outcome. That's part of the application. We have to send that into Olav Thun, where you look at the knowledge and the skills that the students are going to build out. So this is just how we see the class, explaining processes influencing marine geological environment, classify and exemplify the most important marine erosions and deposit forms, show up the main lines of the geological development history and the study area, use the most recent method to reconstruct marine environments, erosion and deposit story, and explain methods that can be used to reconstruct and evaluate climate change and how climate variation can be reconstructed from marine archives. When we look at skills, we want the students to plan and carry out fieldwork and process and interpret data, use marine geological sample methods and analyze marine data, demonstrate analytical skills, critically evaluate data from various marine investigations or methods, interpret research data and discuss their use by studying, for instance, climate processes or environment, geohazards or geological history, and strengthen their skills in research methods, oral presentation, scientific writing, and discussion. And the competence that we want the students to build is to formulate hypotheses, design, lead, and carry to experiment, the quiz itself, inclusive identification of relevant geological and geophysical methods to evaluate the hypothesis, make use of critical thinking and physical understanding, integrate, analysis, interpret data from various sources, and demonstrate interdisciplinary understanding about coupling different research areas, present and discuss research strategies, and critically evaluate methods in relation to results. And also communicate research results and their significance. So the planned startup for the project is already started and is ending in June 2023. And we asked for money to basically have this workshop at the kickoff workshop. We asked for money for more student assistance. We asked for money to get some new equipment. For instance, we want to put up a real nice sort of digital microscope for training the students. And also we have a good slush sum for adding to some of the marine equipment on board and do analysis. We want the course to be evaluated every year and that it be a continuous development of the course along the way based on the evaluation and experience. So far now we're going to sort of merge some of the new into the old, and I'm going to co-teach this class with my colleague Hofledy that's teaching it now, and Ulysses is gonna, he's running the iStope lab, so he'll develop more of that measurement technology into it. So right now I'm discussing with the University of Bergen's teaching lab how to develop the digital modules. They have great experience in doing the same for medicine. So I got that team that's been working with medicine to help. I mean, it goes on everything, how to make smear slides, how to actually use the microscope, how to prep for isotope analysis, prep for water samples. And the reason the medicine people do it was that there was a limit on how many corpses they could use. There was a limit on how many mouses they could use. There was a limit on how many tissue samples. And so the students are familiarized with a lot of the lab methods to the digital modules. And also virtual method courses, educational films, and pre-arranged lectures for the blended learning part. So this will be developed during each autumn semester. So the course will start in 2021, but the project is already running. And the last year, I've enjoyed very much taking course modules under the auspice of the program for University Pedagogy, UniPed. I have to say that the basic intro class I took, the one we all have to take to be teachers, didn't really inspire me so much. I was lucky because we had it up in Boston. We had a lot of wine tasting, and we went skiing and had a lot of fun in the afternoons. But these little classes where the focus is like, how do you make a really good instructional video? How to design and teach blended courses? Actually, how to really use our teaching platform at UAB. We have Canvas, and also assessment and assessment methods, team-based learning, and small-scale virtual technology. They're incredibly inspiring, and one of the reasons they inspire me so much is that I meet people from all over, from all the 7 faculties that are coming with their background and their knowledge and their experience, and we share that. And I think that is for me, the biggest sort of learning outcome of taking the Uniped classes. I get very inspired from what other colleagues are doing across the university. And there's a lot of good things happening that, so we don't have to invent the wheel all the time. Sometimes people have made a beautiful module that you can ask somebody to copy and make it geology. So this is the milestones. We need, of course, to down the road get this class changes, get them into the program sphere. What's going to happen? We're going to develop modules, carry the courses through, and keep on sort of module development all the time. I think this class is never going to be frozen in time. The class is always going to develop, and it's a 10 credit class. It's on 200 level. Usually it has around kind of 20 students or so, and I also want to say that it's a very popular class for exchange students. So this is a class that has really high standing out of Europe. A lot of the sort of leading labs are often sending their students up or saying, go to Bergen, take the marine geology class, take the paleochrometry class, take stabilized geochemistry, and then you're set for your master's. So this is also a class that we should spend a little bit more time on trying to get out there in Europe. Okay, so one of the kind of major reasons for designing and starting this class is, of course, to not just to make a class for the students and have fun with making it more digital and cooler, but also try to educate ourselves a little bit, try to get more competence, and try to build in some of the new learning skills and learning techniques. You see the word SOTL up there. So we're also going to try to develop ourselves, or develop our pedagogical portfolio of this, and try to have a systematic reflection of our own teaching along the course. First of all, it will be important for our own development, and really kind of jog our brains and change how we are carrying on and doing our teaching. But also, it can be important for pedagogy. It can be important didactically or geoscience learning-wise within our own research group and for the department and for iEarth. So we hope that the experiences that we are making and the knowledge that we're building for this can be further evaluated, and maybe we can meet again once a year and talk about how this class is going and what we are learning from trying to change how we think about teaching first and foremost, but also how we will try to carry this through. And also on a third level, maybe we can also try to bring this out to a larger audience. Maybe this is something that could be researched and try to see the outcome for the students, try to see and measure learning with new methods. Maybe it's good to have a baseline study and see what's happening after we really completely change the class. Maybe it could be presented on a conference or written in a paper. So that's basically kind of what I wanted to say. And I think that was the